I want to talk about programming C# from the very beginning. So we need to first of all download C#, say from Microsoft. So you can do a search for downloading C# Visual Studio, and for example Visual Studio Community is quite good, free of charge. So we could go through the motions here and download, and then save this file, and then you can just execute that file, and then go through the procedure of installing C# Visual Studio, in fact. So once you've got that installed, then we can therefore just I'll just move this out of the way, and we can click on you'll have something like this where you can just double click on that and start Visual Studio. Now, so what we need to do is to build a C# program. So we'll go to File, New Project, but make sure you choose the Visual C. We've got Visual C++ and so on. We've got Visual. We can do here. We've got the most important thing is the console application. That means your output will eventually appear in a black screen, and we'll give it a name. We'll call it the XP for experiment, short name, and then click OK. Now it's done quite a bit for us actually. It's going to produce a project, and now what we've got here is the solution, which is called EXP, and within that solution there's a project called EXP, and it's very kindly made a source code file for us called program CS. We could call that anything we liked actually, that source code file, and indeed you can call all these anything you like as well. But notice what we've got here. We've got a bit more than what we asked for, so I'm going to get rid of just a bit of this here, and for the moment I'll just ignore this bit here as well. So this is our basic program. Now we've got this is the entry port of the program here, and this is where we write our program between these two curly braces. This thing here is called a function. We've got quite a lot of complications here in that what all we want to do is to go ahead and write some programming, and this is in fact where we write our program in here inside main. Now what is main? Main is actually a function, and we don't really talk about functions till through the course, so for the moment it's a function. Static means it doesn't need an object to operate the function. All of this doesn't mean a great deal, and don't worry that it doesn't, because all we're interested in writing our program, which is going to go here. Void means that the function returns nothing, for example, but basically just do that, just write that stuff and put your curly braces, and we don't need to write it, it's written for you if you make a new program in C#. Class program, here's another complication actually, that what is this? Well, we don't learn about classes till much later on, so just for the moment just leave it there, and that's where what's it used for? Well, later on when we want to make an executable. What does that mean? It means when we compile the program. I'll explain what that means in a moment. So it's a little bit tricky to explain to you what classes mean and what functions means, and even even this bit, this namespace. Namespace is it's a way of avoiding name clashes in one instance, so that we can distinguish from our program to somebody else's program if we're using the same variables. So all of this is a little bit meaningless at the moment. You could in fact do away with that namespace. In fact, that's what I'll do, and pare it down to the absolute minimum of a program, and that means we can therefore start to write some code within that. So in summary then, just make sure you've got this stuff here in order to be able to write your program in there. So what we're going to do is to make a simple program, and I'm just going to copy this from elsewhere on the other screen. As a matter of fact, I'm copying some code here, and I'm going to paste this code in. Now right, and I'm going to now build the code and build the solution, and then I'll explain what that means in a moment, and then we'll go ahead and click here, you see, and run the program. Or you can, let's see, you can go it through here, start debugging, you can run it from there, or indeed you can press the F5 key. But you can see over here that it is successfully built, so we're ready to run it. So I'll just click up here, and that will run the program, and there's the output there, you see. It's printed hello world. Well, what are all these other bits and pieces in the program? We've got here console write line. Now console indeed is this black screen here, and write line is what you're going to do. You're going to write that line, and this is the bit of text. It's in inverted commas because it's text, and you print that to the screen. Now there's a bit of a complication with this, because we've got this thing here called console read line. What that's doing is reading a character from the keyboard. Now, which is here, you see, it's there ready, waiting for something. So if I actually give it something, I'll press the enter key, you'll see the screen will disappear. Now the idea of this is that it actually holds the program up. Let's see what happens when I do without it. Now when I say do without it, I'm going to put what I call a comment. I'm going to comment it. Comment means you put these two forward slashes, and therefore that line will take no further part in the program. Now if I build my program again and then I run it, you'll have to watch very carefully, because now, are you ready? Go. See it? Whoosh, gone. The screen is gone. So this thing here has the effect of holding up the screen. You won't see it in many textbooks, and it's a little bit disconcerting. If you build this program, it just sort of disappears and you wonder what on earth is going on. But there is an alternative to this, by the way. The other way of doing this, if I just build this, the other way of avoiding having to write that read line all the time is to go through here, debug, and then start without debugging. That will also keep it up on the screen as well. But I actually prefer to include this. Now, what is this thing up here? System, using system. What that does basically, it includes the code for such things as these, you see. So it contains the C# programming, if you like, for the moment. We can avoid doing that. Well, I'll just comment that out, and then I can actually double click on this and copy it and paste it in here. See, it's complaining at the moment. So if I paste that in there, and you see, and then I can paste it in here as well. I'll copy it there and just paste it, and then you see, if I build that, that is exactly the same thing. That it will improve that by running it, but and that just works exactly the same. But to save yourself, I'll just press the enter to get rid of that. But just to save yourself all of that, you could just get rid of those, and then just get rid of the commenting out as well, and that's our basic program. Other things we need to watch out for, besides indenting properly, is for example, C#, you always have a semicolon after the end of the line. Well, you don't have one here because it's sort of got the curly braces. It's a unit. It's a class, in fact, of code. And the same with this main. You don't have a semicolon after that because that's like a function, which I say we're going to talk about later. But for the moment, basically we've got a semicolon after every programming line. Now notice that it's actually very case sensitive as well as C#, and the inconvenience is that it won't actually capitalize it for you, so it'll complain, which is fine, but you need to be very careful in typing. It's a bit of a nuisance in a way, but you have to be very careful about what you type. There are shortcuts of typing. For example, if I want to say console write line, I could do CW and then tab, and that will do it for you. So that's a useful tip. I think okay. Right. Well, what I want to do is to explain the building and running as two separate processes. What I'm going to do is to go try and find well, let me just take a look. If I go File and then Open, then open my project, open the file is what I want to do, and not easy to find these sometimes, but let's see, I've got exp here, where am I, dd, binary, debug, that's what I'm looking for here. This is the executable program. Now, if I could actually run that, you see, if I drag that, that's a standalone program, and if I double click on that, it actually works, you see. So that's the program itself. I'll just plonk that back in there. Hello. Copy that. Did you cut it indeed, and then paste it in here? That's fine. That's back in order. Now, but what I'm going to do, I'm opening that file. I'm going to open to see what the file actually looks like. Now, this file, I'll remind you, is the product of building the program, and then when I run it, it runs. I just showed you I could double click in this instant to run it, but the building process produced this. Now I'm going to take a look at that file, and I'm going to open with, a bit unusual, you may not have this on you, but I'm just going to take a look at that file using a binary editor. And if I click OK, then this is what the file looks like. Well, you know, it doesn't look very useful, does it? Well, this is all meant for the microprocessor, so the microprocessor will understand. Well, you've got a microprocessor which looks something like this, your microprocessor, and what you're actually doing. Well, there's the file there. You see, and if you look at the first byte, we call this, it's called 4D. It is 4D, and let me tell you, that's got the value of 79. This is hexadecimal that we're looking at here. Hexadecimal is base 16. I'll explain that to you later, but take it from me, 4D actually just means 79 in decimal. And also take it from me that 79 can be written in binary like this. Now, in computer the 1 represents, say, 5 volts, and if you look at your microprocessor, you're putting 5 volts on one leg, and then you're putting 0 volts on another, and so on, and you can actually represent the number 79 on the microprocessor like that. Now that's all a bit technical, but all I'm really trying to let you know is that this code here, which is the executable code, it only makes sense to the microprocessor. Now, and that when we convert our program, which was this, by the way, there's our program, and we actually went ahead and built it, you remember. And when we say build, we actually mean compile. Compile means to convert it to ones and zeros, which only the microprocessor understands. So all we're trying to point out that this is a two-stage process. First of all, we have our program, which is sort of like English, but then you build the program, and when you build the program, build the solution, you produce this thing here, which is known only to the microprocessor. I'll just close that, in fact. Now, and then you know that the next, by the way, that little asterisk up here means that it's not saved as yet, so I might as well just save it. But you know that now when you build it, you produce the executable, and when you've done that, you see that run will run the executable, the exe file that I just showed you.